Okay, I've used the term reference angle multiple times in the past couple days, but we haven't officially talked about it. So before I give you the formal definition, I'd like to give you a few moments to talk about what you think a reference angle is with the people that you sit by. Go.
I don't know.
Five, four.
You kind of said it was like a starting point, almost.
A starting point?
Yeah.
Okay. Okay.
It's near a certain point.
And near a certain angle. Okay. 5, 2. You're at a loss. Okay. 5, 1. Robert?
Me? Oh, I said it's like, I don't know, I thought it was like, you could say it's like 30 degrees from something, like an angle.
Okay, so it's like a measurement, how far we are away from,
The wire outside.
okay, one of the axes, all right? 5, 3, anything to add or subtract? Okay, so angles in the first quadrant, which are acute, right? And that's what we reference back to. All right, 5, 5, anything to add or subtract? No? Formally, probably should plug in. If I can find the cord. Formally, if we have an angle theta, its reference angle is acute, and it's the angle between the terminal side of theta and the horizontal axis.
Does it count as compliment?
No, it's kind of not. We'll draw pictures. Okay. Okay, so the acute angle, we're going to call it theta prime, formed by the terminal side of theta and the horizontal axis. Today we're going to focus on reference angles on the unit circle. So today's going to be pretty relaxed because we've got the unit circle down, or almost. And then tomorrow we are going to talk about reference angles that do not deal with the unit circle. Okay? When I say tomorrow, I mean the next time I see you. if we have an angle that is in the first quadrant, what is its reference angle? The same thing. In the first quadrant, we're already acute, right? Back to the x-axis, that's how we measure, all right? So in the first quadrant, the reference angle is itself, okay? Not really helpful there. If our angle is in the second quadrant, however, by definition, our reference angle goes from terminal side to horizontal axis. This guy would be our reference angle. What's the relationship between theta and the reference angle? Supplementary. Those have to be 180 degrees or pi radius. What? Okay. Third quadrant. If this is theta, reference angle terminal side to x-axis would be this guy right here. What's that relationship? How would we find that theta prime if we knew theta? We would have to subtract 180 from the angle to get what's left over past 180. Okay? Or pi, whatever you're in. Just make sure that we're talking about a positive acute angle. Reference angles are always positive. Okay? And then last but not least, our fourth quadrant angle would look like this. Our reference angle, terminal side to x-axis, would be here. And what would that relationship be? What do those two angles make? 360. So to find the reference angle, we could take our fourth quadrant angle and subtract it from 360. Okay? Now, we are going to focus on unit circle values today. So our knowledge of reference angles won't be super important, but it's a good way to kind of ease into it for when we talk about non-unit circle values. Okay? So what I'd like you to do, I am going to put an angle on the board. I'd like you to write it down and then draw it for me. So 315 degrees, write it down and then make a teeny tiny XY axis and draw the angle. Which quadrant is 315 degrees in? And we can be pretty exact. We know that that has to be halfway through. There is 315 degrees. If we wanted our reference angle, Brooke, what would it be? And how did you get 45? Okay, if we subtract 315 from 360, we get 45 degrees. Okay? Now, let's talk about that reference angle. 45 degrees and 315 degrees, their xy coordinates both involve radical 2 over 2, radical 2 over 2. There's just positives, negatives in different places. That is because the reference angle on all of those would be 45 degrees. Okay? So all of the angles that have reference angles of 45 degrees have coordinates that are similar. Radical 2 over 2, comma radical 2 over 2, with positives, negatives, depending on which quadrant. Okay. Next one, 7 pi over 6. Write it down and then draw it. Adrian, which quadrant? 3? Like that? Great. So our reference angle would be right here. Okay. Our reference angle would be what, Jake?
5/6.
And how did you get pi over 6?
Knew that 180 was just pi.
Mhm.
So needed to
Okay, so this is just pi over 6 past pi, is what you're saying? Good. So pi over 6 and 7 pi over 6. Since pi over 6 is the reference angle, their coordinates are going to be similar, just with positives and negatives in different places. Okay? Same thing with 5 pi over 6 and 11 pi over 6. Since they all have reference angles that are the same, their xy coordinates are going to be the same with different positiveness. Okay? That's what I want you to understand about the unit circle. Okay? Now, I'm going to put up here, one at a time, there's 3 calculations I want to make. Very similar to what we did on the blue worksheet, but they're not all straightforward. Okay? I'm going to put up a calculation. I want you to write it down, and then you have about 20 seconds after you write it down to answer it. Okay? You can do it. First one, cosine of 4 pi over 3. Write it down, calculate it. Brandon, what's the cosine of 4 pi over 3?
I haven't got it
Okay, still thinking? Brandon's asking, is it radical 3 over 2? How would I ask you this, Brandon? Do you agree that the reference angle is pi over 3? Yes. So what is the coordinate at pi over 3 on the unit circle? At pi over 3, the xy coordinate, there is a radical 3 over 2. Is it the x or the y? Okay? So then the x is 1/2. Okay? So the x is 1/2, right? So cosine of 4 pi over 3. Good. And since we're 4 pi over 3, would it be positive or negative? It would be negative because we'd be in the third quadrant, right? Okay, good. See how I talked him through that? Okay, the reference angle is pi over 3. And like I said, if you know the first quadrant, you should know it all, right? First quadrant, we recalled the coordinate. We know cosine deals with the x, and then we decided whether it should be positive or negative based on the quadrant. Okay? All right, here's another one. Tangent of negative 210 degrees. Negative 210 degrees is the same as what positive angle? 150. So this is the negative 210. Since its coterminal was 150, finding the tangent of 150 degrees would be the same. Hey, Jackson, what do you have?
Negative radical 3.
Can you talk me through how you got that?
Well, I know since it's 30 degrees away from the x-axis, so which means the long side would make it radical 3 over 2, and then going up it would be 1/2, and then tangent is y over x. And did I do it backwards?
As you just talked through it, you realized that, didn't you? You went up 1/2, right? So y is 1/2. X is radical 3 over 2. So the 2's cancel, we're left with 1 over radical 3, which reduces to?
Radical 3 over 3.
Okay? And since we're in the second quadrant, you put the negative there. Okay? Now, if somebody first time would say, oh, well, it's negative, so I'll just take this out. Tangent of 210 is radical 3 over 3, and so then it's negative. No, that negative has to stay in there. You have to think about the angle of negative 210, where it's at, and then determine positive, negative. Does that answer your question?
Yeah.
Nobody did. You don't have a question? Okay. Next one. Cosecant of 11 pi over 4. You got it? You got it? The more you know the unit circle, the more comfortable this is. Eleven pi over 4, where is that? It's in the second quadrant. We go around once and then 3 pi over 4 more. So it's the same as evaluating the cosecant of 3 pi over 4. Okay? So the cosecant of 11 pi over 4, which is the same as the cosecant of 3 pi over 4. Robert, what do you think? How'd you mess up?
I did the wrong angle.
What angle did you do? Okay, so similar process though, right? So all that's going to be different is like a positive or negative, potentially, right? Okay, so just talk me through how we're going to do it.
So
What's our reference angle?
45 degrees.
Okay. Cosecant is the reciprocal of sine. What's the sine of 3 pi over 4?
Right, 42.
Okay, so when we take the reciprocal of that, what do we get?
3 radical 2.
Which is radical 2. Okay, go ahead and reduce that. All right. Since we're in the second quadrant, secant, reciprocal of sine would be positive. Okay. All right. Good. Now we're going to go backwards. Now I'm going to give you, like this, the cosine of theta equals 1/2, and we need to determine where on the unit circle between 0 and 360, between 0 and 2 pi, the cosine is 1/2. So go ahead and write down cosine of theta equals 1/2. We're finding theta, okay? Now, if I label this, all students take calculus, where is the cosine positive? in both the first and the fourth quadrant. So we could have two answers here, couldn't we? Okay, so cosine deals with the x-coordinate. Where in the first quadrant is the x-coordinate 1/2? 60 degrees. So we know that theta is 60 degrees, or pi over 3. But then cosine is also positive in the fourth quadrant. So with a 60-degree reference angle, where would we be in the fourth quadrant? 300. If we're talking about radians, pi over 3 is our reference angle. We'd be at 5 pi over 3. And there we go. Not as scary as you thought it was going to be. Most of the times, you will get two answers, two angles, but there are very few cases where you might only have one, and that would be at like a quadrangle angle. Okay? All right. Let's write this one down. Okay? Radical 2 makes us think of what angle? Our 45-degree reference angles, right? So in your head, you already kind of know what your reference angle is. Cosecant's the reciprocal of sine, so we know that in the first and the second quadrant, we have positive sine ratios, right? So first quadrant, what's our degree measure? 45. Radians, pi over 4. So switching back to degrees, if 45 degrees is our reference angle, where are we in the second quadrant? 135. If pi over 4 is our reference angle, where are we in the second quadrant? 3 pi over 4. Next one. Undefined. Tangent is undefined, probably not in a quadrant. Would you agree? It would have to be on one of the axes. Which axis should we focus on? X-axis or Y-axis? I heard Y, I heard X. So let's just write down all four. Tangent is Y divided by X. When we take Y divided by X, which axis would be undefined? Okay. So at 90 degrees and at 270 degrees, we would get 1 over 0 or negative 1 over 0. That is undefined. In radians, pi over 2 and 3 pi over 2. Yes. All right, we have 2 more examples. And then I have a job for you. Sine of theta equals 0. Write it down and see if you and your pod can come up with where the sine is 0. Brooke, what do you think? What are our angle measurements? 0 and 180 degrees. Do you agree with Brooke? No? To an extent.
It's going to be 360 degrees also.
So, what the directions that you will get, and I didn't really point these out, will be from 0 to 2 pi and 0 to 360. We don't have to include 2 pi and 360 because it's being redundant, right? If you do, I'm not going to get upset, but you don't have to repeat it, okay? So yes, at 0 and 360, or excuse me, 0 and 180, our y coordinate is 0. All right, last one. And then I'm going to give you a test. Okay, so you need to figure out the reference angle. Some of you are going to know it right away because you remember when tangent is radical 3 and when it's radical 3 over 3. Some of us have to think a little bit. Not a problem. Which two angles do we know we have to narrow it down to? 30 or 60. It involves a radical 3. It's either 30 or 60. Okay? We know that our cotangent ratio is x over y. Okay? So what we have to decide, is it 1/2 over radical 3 over 2? Or is it radical 3 over 2 divided by 1/2? Which one of these ratios will get us radical 3? The second one. When we have the second one, the 2's cancel out and we have radical 3 divided by 1. Which is a 30-degree angle, right? If x is radical 3 over 2, y is 1/2, we are talking about 30 degrees or pi over 6. Cotangent is the reciprocal of tangent. Which other quadrant is it positive in? The third. So if our reference angle is 30 and we're in the third quadrant, our angle in degrees would be 210. In radians, 7 pi over 6. Okay, this is what I'm going to ask you to do. We have about 8 minutes left in class. I know that if I give you work time, probably not going to happen. Okay? So, we're going to get some practice in ourselves. I want everyone to get out their unit circles. Okay? And you're going to partner up at your table. Okay? Now these two tables right here, you're just going to take turns quizzing each other as a trio. Okay? So just do it. All right, so what you're going to do is you're going to take turns quizzing each other. If the person is being quizzed, their unit circle is turned over. If the partner, whichever partner is being the quizzer, they get it. So Jasmine would say, Colby, when is the sign 1/2? And Colby would say, well, that would be at both 30 degrees and 150 degrees, or pi over 6 and 5 pi over 6. And then they take turns asking each other back and forth. Okay? So for the rest of class, you're going to take turns quizzing each other. So you come up with the questions, they answer it back and forth. Does that make sense? Ready, set, go.